Welcome to the Deep Dive. Today we're tackling service workers, a seriously powerful tool for modern web applications.
Yeah, really fundamental stuff.
We've got a fantastic collection of resources to pull from. There's a YouTube video transcript breaking down push notifications, the authoritative MDN web docs on the service worker API.
Can't beat MDN for the details.
Exactly. Then a super practical blog post on how to actually debug these things, which sounds important.
Oh, definitely. Debugging can be a bit of a headache sometimes.
Also, a great tutorial from UploadCare, an insightful Chrome for Developers article on caching strategies, a web.dev piece exploring the service worker lifecycle.
The lifecycle is key, yeah.
A Reddit thread packed with, clever real-world examples, another web.dev article on how different parts talk to each other, and a straightforward study tonight tutorial to get you started writing your own. Whew!
That's quite the list. So our deep dive today has one core mission, really, to cut through all that technical detail and get to the heart of what service workers are actually about.
Right. What can they do? Why should you care?
Exactly. What they can do for your web experience is why they matter. We're aiming to give you a solid, sort of intuitive understanding of this technology and, its potential.
Okay, service workers. The name itself sounds a bit, I don't know, mysterious. What exactly are they?
Yeah, it does sound a bit technical, doesn't it?
Yeah.
Think of a service worker as a smart, kind of behind-the-scenes assistant for your web application.
An assistant. Okay.
It's essentially just a JavaScript file, but it runs separately from your main website in the browser on its own thread.
So it doesn't slow down the main page loading.
Precisely. That's a huge plus. Its key role is to act as a proxy, like a go-between, for your web app, the browser itself, and the network.
A go-between.
Yeah, this unique position lets it intercept and manage network requests. It can grab them before they even reach your server or your website's main code.
So this background assistant can jump in and handle things before my website even gets involved.
Exactly. And it's event-driven. That means it only wakes up and does something when a specific event happens, like a request for data from the network, or maybe a push notification arrives from a server.
Okay.
Each service worker is tied to a specific website, its origin, and a defined path, which we call its scope of control.
Bope, right?
What makes them really powerful is their ability to enable offline functionality. They do this by managing a separate cache of your website's files.
The cache.
Right. And they intercept those network requests we talked about to serve content from that cache. They can handle various caching strategies to make your site faster, more reliable. Plus, they're the foundation for features like push notifications,
Which you mentioned.
that can re-engage users, and also background sync, which lets actions complete even if the user, temporarily loses their internet connection.
Okay, you mentioned push notifications. We have that YouTube transcript that focuses on them.
Yeah.
It sounds like it's more than just those little alerts that pop up sometimes.
Yeah.
It's a way to really reconnect with users.
That's absolutely right. The transcript clarifies this distinction between push notifications, which are triggered by a server sending a message, and local notifications.
Local ones are different.
Yeah, local notifications are initiated by something the user does directly within the app itself. But the real engagement power, like you said, comes from push notifications.
Because they come from the outside, even if the app isn't open.
Exactly. They let your website reach out to users even when they don't have the page actively open in their browser. Think about getting a notification on your phone about a new message in an app, right?
Yeah.
Push notifications for the web work in a similar way. They draw users back to your site with timely updates or information.
So what are the essential pieces needed to make these server-initiated notifications actually happen on the web? What tech is involved?
Okay, you need a few key technologies working together. First, obviously, there's the service worker API itself, which gives you the framework for running that background script.
Right, the assistant.
Then you have the notification API. That gives you the tools to actually create and display those pop-up alerts to the user.
The visual part.
Yep. And finally, there's the push API. That's the channel, the mechanism through which servers can send messages to the user's browser.
Got it. Service worker, notification, push.
And the service worker is the crucial link in that chain. Why? Because it's the only part of your web application that can be running in the background, constantly listening for these incoming messages from your server.
Always on standby.
Pretty much. When the server has something to send, it uses the push API to deliver it to the user's browser. The browser then wakes up the associated service worker, and the service worker, in turn, uses the notification API to generate and show the actual notification to the user.
Okay, that flow makes sense.
Huh.
How does it start?
Well, it starts with the user. They have to grant your website permission to send notifications, usually via a prompt using the notification API.
The little allow notifications app.
Exactly that. Then your website uses the push API through the service worker to subscribe the user to something called a push service. From that point on, the service worker is ready to receive and handle those push events from your backend. It's like having a dedicated messenger constantly on call.
That makes sense in always listening channel. Now, several of our sources, including MDN, talk about the service worker lifecycle. That sounds pretty critical to how they function and, importantly, how they get updated.
It is indeed fundamental. The life cycle describes the different stages a service worker goes through, from the moment it's first registered to when it's actively controlling your web page, and even when it gets updated later on.
So what are the stages?
The first time a service worker is registered for a site, it goes through 3 main phases: download, install, and then activate.
Download, install, activate.
Okay. During the install event, your service worker gets a chance to set things up. A really common task here is to cache essential files for your website. It uses a method called event.waitUntil to make sure the browser doesn't kill the install step before the caching is done.
So it's like prepping its toolkit during install.
Exactly. Think of it like that. Once the installation is successful, it moves to the activate phase. And this activate event is a really opportune time to clean up any old, outdated cached files from previous versions of the service worker.
Ah, housekeeping.
Right. Ensures your service worker is working with the latest resources and you're not cluttering up the user's storage.
Okay, so that's the initial setups. Download, install, activate. But what happens when the website is updated and there's a new version of the service worker script? How does that work?
Good question. When the browser detects an updated service worker file, and this can happen when a user navigates to a page within the service worker's scope, or during certain background checks if it hasn't checked recently, like maybe every 24 hours,
Okay.
or even if the service worker's file URL changes during registration, though you generally want to avoid that last one, the browser will download the new version in the background.
Without interrupting things.
Right. It tries to install this new version without disrupting the currently running website. Now, here's where a clever mechanism kicks in for smooth transitions. If there's already an active service worker controlling the current page, the newly installed one enters a waiting state.
Waiting, so it doesn't just take over.
Nope, not immediately. It will only become the active worker once all the existing pages that were being controlled by the old service worker are closed or navigated away from.
Ah, so it waits until the coast is clear.
Pretty much. This ensures a seamless update process for the user. They don't suddenly get weird behavior because the underlying controller changed mid-session.
So it's really designed to avoid any jarring interruptions for the user while the website updates its background assistant. That's smart.
Exactly. But developers do have some control over this. There's a method, self.skipWaiting, that you can call, usually in the install event handler of the new worker.
Sick waiting. Okay.
This tells the new service worker, hey, activate as soon as you're finished installing. Don't bother waiting for the old one to be fully retired.
Useful for getting updates out faster, maybe.
Potentially, yeah, especially during development or if the update is critical. And there's another piece. The currently active service worker can use something called clients.claim.
Clients.claim.
Yeah, this lets an activating service worker immediately take control of any existing pages within its scope that weren't initially under its control. Usually, this control only happens on the next navigation or refresh, but clients.claim makes it immediate.
Okay, so more control for the developer there.
Definitely. And once a service worker is active, that's when it can start intercepting network requests during the fetch event using event.respondWith. This gives it the power to decide, serve a response from its cache, or let the request go to the network. It offers a lot of flexibility.
The scope of a service worker is also mentioned quite a bit. It sounds like that defines just how much of a website the service worker can actually influence or control.
You're absolutely right. When you register a service worker using navigator.serviceworker.register, you give it the path to your service worker script, like SWJS.
Yeah.
The default scope, the extent of the website the service worker will control, is basically the directory where that script file lives and everything underneath it. So if your SWJS file is in the root of your website, then by default, it will control your entire site.
Okay, root means control everything.
Generally, yes. But you can explicitly define a more limited scope during registration if you only want the service worker to manage, say, a specific section of your website, like app.
Useful if only part of the site needs offline features.
Exactly. And it's crucial to remember pages that are loaded before a service worker becomes active and takes control won't have their subsequent resource requests intercepted by default.
Hmm.
You usually need to refresh the page, or the service worker needs to use that clients.claim method we just talked about.
Got it. So the first load might not be controlled unless you force it.
Correct.
This all paints a picture of developers having really fine-grained control over how their web apps behave, especially when it comes to performance and reliability. And caching seems to be absolutely central to that control. The Chrome for Developers article really dives deep into different caching strategies.
It does, and it's essential to understand that the cache interface we're talking about here, in the context of service workers, is totally separate and distinct from the browser's built-in HTTP cache.
Oh, okay. It's not the same cache the browser uses automatically?
Nope. While the HTTP cache is managed automatically by the browser based on HTTP headers, the service worker cache gives you, the developer, much more direct, programmatic control. You decide exactly what gets stored, how it's stored, and when it's retrieved.
More power, more responsibility.
Pretty much. The cache storage interface acts like a central hub for all the named caches associated with your service worker. You can have multiple named caches, maybe one for static assets, one for API responses, etc.
Okay, named cache.
And each individual cache is then represented by a cache object. The key methods you'll constantly use when working with these caches are things like cachestorage.open that either creates a new named cache or opens an existing one.
Right.
Then cache.add and cache.put are used to store responses, often ones you've just fetched from the network. Cache.match is how you look for a cached response that matches a given request. And cache.delete lets you remove specific items from the cache.
Okay, open, add, put, match, delete.
Yeah.
Basic cache operations.
Exactly.
And the request property within the fetch event seems to hold a ton of information about the incoming request. That sounds vital for making smart decisions about caching.
Precisely. The request object that gets passed to your fetch event listener is packed with useful details. You get the URL being requested, obviously. You get the HTTP method, like DET or POHOST. You get the mode, which is often navigate when the browser is requesting an HTML document itself.
Navigate, okay.
And you get the destination, which tells you the type of resource being requested, like image, script, style, document. By examining these properties, your service worker can make really intelligent decisions about which caching strategy to apply for that specific request.
So what are some of these common caching strategies that developers actually use in practice?
Right. The Chrome for Developers article and the Upload Care tutorial outline several popular patterns. One really basic strategy is cache only.
Just serve from the cache, period.
Yeah. The service worker exclusively serves responses from its cache. This approach means you have to have pre-cached everything necessary beforehand during the install phase, usually.
Okay, what else?
On the complete opposite end is network only. Pretty self-explanatory. The service worker completely bypasses its cache and always goes straight to the network.
When would you use that?
Maybe for things that must always be live, like, I don't know, stock prices or something highly volatile where a cached version is useless.
Makes sense.
Then a very, very common and effective strategy, especially for static assets, images, CSS, JavaScript files that don't change often, is cache first, falling back to network.
Cache first. Okay.
Here, the service worker intercepts a request, first checks its cache using caches.match. If it finds a match, boom, serves it immediately. Super fast.
Nice. And if not?
If not, then it fetches the resource from the network, stores a copy of the response in the cache for next time, and then returns the network response to the web page.
Best of both worlds for static stuff.
Pretty much. Now, for more dynamic content where freshness is really important, you might flip that and use network first, falling back to cache.
So try the network, then cache if it fails.
Exactly. It tries the network first. If that succeeds, great. You get the freshest data and maybe you update the cache. If the network fetch fails, maybe the user's offline, then it looks for a cached version as a fallback.
Good for things that need to be current, but should still work offline.
Right. And finally, there's a really popular one called stale while revalidate.
Stale while revalidate. Sounds interesting.
It is. This strategy prioritizes speed above all else. It immediately serves a response from the cache if one is available, making the page load feel instant.
Okay, serve the old stuff right away.
But at the same time, it also sends a request to the network in the background to fetch an updated version of that resource.
Ah, and updates the cache silently.
Precisely. It updates the cache with the fresh version, so the next time the user requests that resource, they'll get the updated one. It's a great way to provide a super fast initial load while ensuring the user eventually sees the latest content without waiting for it.
That stale while revalidate sounds like a really smart way to balance speed and relatively up-to-date content. You get something on screen quickly, and then it just quietly updates in the background. Very clever.
It's a very popular and effective strategy, yeah.
Now, we've been focusing quite a bit on service workers. The Upload Care article also briefly mentions web workers and how they're different. What's the key distinction between these two? Because the names sound pretty similar.
That's a really important point to clarify. You're right. The names are similar. And both service workers and web workers are background scripts. They run independently of the main browser thread, which is great because it prevents them from blocking the user interface.
So they both help keep the page responsive.
Correct. And neither type of worker can directly manipulate the document object model, the structure of your web page. They have to communicate back to the main thread if they want changes made to the UI.
Okay, background, no direct DOM access. What's the difference then?
Their primary purposes and the specific functionalities they offer differ significantly. Service workers have that unique and crucial ability we've been talking about. They can intercept network requests via the fetch event.
Right, the proxy thing.
And they can listen for push notifications sent through the push API using the push event. Web workers simply cannot do either of those things.
Ah, okay. So web workers can't intercept network requests or handle push messages. That's a big difference.
Huge difference. Also, a single service worker instance typically controls all the active tabs or windows that fall within its registered scope for a given website, whereas a web page can spawn multiple web workers, and each one operates more independently, often just for that specific page.
One service worker per scope, potentially many web workers per page.
Exactly. And the life cycle is different too. A service worker's life cycle is decoupled from the web pages it controls. It can keep running in the background even after all associated tabs are closed, waiting for events like push notifications or maybe a background sync trigger.
It outlives the tabs.
It can, yes. In contrast, a web worker's life is tied directly to the tab that created it. When that tab is closed, the web worker is terminated.
Okay.
And one final really important distinction, security. Service workers, because they can intercept and modify network requests, are only enabled on websites served over HTTPS.
HTTPS only for security.
Yep. Ensures that the intercepted network traffic is encrypted and protected. Web workers don't generally have this strict HTTPS requirement because they don't have the same network interception capabilities.
So if I'm understanding correctly, web workers are more about offloading heavy calculations or tasks to a background thread within a single web page just to keep that page responsive.
Generally, yes. That's a primary use case.
Well, service workers have a much broader network-level role. They manage requests, handle caching, enable offline access, deal with push notifications, all potentially across an entire website scope, even when tabs are closed.
That's a perfect summary. Exactly right. And just briefly, there are other types of worker tech too, like shared workers, which multiple scripts or windows from the same domain can connect to.
Shared, okay.
And worklets, which are even more specialized, lightweight workers for things like low-level graphics rendering or custom audio processing. But for enhancing web apps with offline, caching, push notifications, service workers are the dedicated, powerful tool.
Gotcha. Now, all this power and flexibility sounds fantastic, but what happens when things inevitably go wrong? That blog post from ZPalm on service worker debugging best practices seems like it would be absolutely invaluable in those situations.
It absolutely is. Debugging service workers can present some unique challenges precisely because they operate in the background, they have that distinct life cycle we talked about, and they can sometimes behave in unexpected ways, especially when you're dealing with caching logic. It's easy to get tripped up.
I can imagine. So what does the post suggest?
It highlights several key strategies and tools. A primary one is really leveraging your browser's developer tools. In Chrome, specifically, it's the Applications panel, and then you select Service Workers in the sidebar.
Applications,
That's
house service workers.
okay. This gives you a dedicated interface. You can see the status of your service worker. Is it running, not waiting, stopped? You can manually update it. You can unregister it entirely.
Oh, you can first an update or just get rid of it from dev tools? That's handy.
Super handy. And crucially, you can set breakpoints in your service worker code right there. You can step through it, inspect variables, just like you would debug regular page JavaScript. It's essential.
Being able to step through the service worker code itself sounds critical.
It really is. Another clever technique the post mentions is deploying a minimal no-op service worker.
A no-op. What's that?
It's basically a service worker that does almost nothing. It just has an install event listener that calls self.skipWaiting immediately and an activate event listener that calls self.clients.claim.
So it installs, activates, and takes control right away, but doesn't actually do anything like caching or fetching.
Exactly. This can be a really quick way to bypass a potentially buggy service worker that's causing problems on your site. If deploying the no-op fixes the issue, you know the problem lies within your actual service worker logic. It helps isolate the bug.
That's a really smart trick, like an emergency off switch for a problematic service worker, just to get things working again while you figure out the bug.
Precisely. It's a lifesaver sometimes.
What other debugging advice does the article offer?
Well, utilizing the offline mode checkbox, which is also in that same service workers section of Chrome DevTools, is absolutely crucial. You need to test your website's offline capabilities thoroughly. Does it work? Is the service worker serving the right cached content when the network is gone?
Simulate being offline easily. Good.
Yeah. And the update on reload checkbox is another huge time saver during development.
Update on reload.
When you check that box, Chrome forces the browser to check for and update your service worker on every single page reload. This means you don't have to manually update or wait for the life cycle. You see the effects of your code changes much, much faster.
Oh, that would speed things up immensely. No more wondering if the old worker is still active.
Exactly. Conversely, there's also a bypass for network checkbox.
Bypass. It does the opposite.
Sort of. It temporarily disables the service worker's fetch handler entirely. All network requests go straight to the network, bypassing the service worker and any caching logic it has. Useful if you suspect the cache is serving stale or incorrect data and you just want to get the live version.
Got it. Update on reload for fast iteration, bypass for network to rule out the service worker.
Right. And for more complex issues, the article strongly recommends implementing comprehensive logging within your service worker code itself.
Console.log everywhere.
Well, maybe a bit more structured than that. Using a library like Workbox, especially in its development mode, is often recommended. Workbox can provide really detailed logs about what the service worker is doing, which requests it's handling, which strategy it's using, any errors it encounters. It gives you much more insight.
Workbox. Okay, a helper library for service workers.
Yes, it simplifies a lot of common patterns and includes good debugging support.
The post also touches on some of the quirks of local development, especially that HTTPS requirement you mentioned earlier. That seems like a hurdle when you're just coding on your laptop.
It definitely can be. Because service workers are so powerful, intercepting requests and all, they are strictly limited to secure origins HTTPS in production. Browsers enforce this.
But my local server is usually just http.localhost.
Exactly. So for local development, this can be a pain. The article points out that Chrome has a flag you can enable. You go to chrome.flags, search for hashtag unsafely treat insecure origin as secure, and you can enter your local development origins like http.localhost.300. Chrome will then treat that specific origin as secure, allowing the service worker to run.
Ah, a workaround flag. Good to know. Does Firefox have something similar?
Firefox has a setting in its advanced configuration page, about.config. You need to search for devtools.serviceworkers.testing.enabled and set it to true. It achieves a similar result for local testing.
Okay, ways around the HTTPS issue locally.
Yep.
What else for debugging?
The blog post also emphasizes using the DevTools to really inspect the contents and quotas of your service worker's cache. That's under the storage section, then cache storage.
Cache storage.
Yeah, you can see exactly which caches exist, what requests and responses are stored inside them, how much space they're using. It's invaluable for diagnosing caching problems like, why isn't this file cached? Or why is the cache full?
See inside the black box.
Exactly. And related to that, using the Clear Storage tab, also in the application panel, is super useful. It lets you easily wipe out all site data cookies, local storage, IndexedDB, service workers, cache storage, everything for that origin with one click. Great for starting totally fresh.
The nuke option, sometimes necessary.
Definitely. The post also reiterates the importance of registering your service worker with the correct scope, like we discussed. Making sure it controls the parts of your site you intend it to control, and not more or less.
Right, scope matters.
And for developers working on actual Android devices, It gives some guidance on how to debug service workers running there, usually involving USB debugging and port forwarding or setting up a proxy, and potentially needing to adjust those Chrome flags on the device itself.
Debugging on mobile too, okay.
Yeah, essential for testing real-world scenarios.
And of course, no debugging discussion would be complete without mentioning how to handle situations when the network is actually unavailable, and also how to manage different versions of your cached assets over time.
Absolutely crucial points. Implementing a robust offline fallback strategy is key for a good user experience. You need to decide what happens when a network request fails because the user is offline.
Show a nice offline page instead of a scary browser error.
Exactly. Or maybe serve cache content even if the strategy was network first. Using tools like Workbox's set catch handler or handling errors in your fetch event listener with the cache storage API directly lets you define this graceful fallback behavior.
Okay, plan for failure.
Always. And to efficiently manage your cache as your site evolves, the article strongly recommends using cache versioning.
Versioning the cache. How does that work?
Typically, you include a version number in your cache names, like my site cache v1, my site cache v2, etc. When you deploy an update with new assets, your new service worker's install step opens a cache with the new version number v2.
Ah, and caches the new stuff there.
Right. And then, in the activate step of the new worker, you add code to find and delete all the old caches, like v1, that don't match the current version. This ensures users get the updates, and you clean up old, unused assets.
Clean and updated. Smart.
Very important for managing cache effectively. Finally, the post advises on optimizing when you register your service worker. Often the recommendation is to do it inside a window.load event listener.
Window.load. Why then?
Because window.load fires only after the entire page, including all images and style sheets, has finished loading. Registering the service worker then ensures that its download and installation don't compete for bandwidth or CPU time with the critical resources needed for the initial page render. It avoids potentially slowing down that first paint.
Makes sense. Don't block the initial view.
Right. And one last small point. Be mindful of how your server handles trailing slashes in URLs, like about versus about. If they resolve to the same content but have different URLs, they might get cached separately, which is inefficient. Ensure URLs are consistent.
Little details matter. That's a really comprehensive set of debugging techniques. Phew. Okay, shifting gears now to something maybe a bit more inspirational. That Reddit thread on brilliant uses of service workers sounds like it could spark some really creative ideas.
It's a fantastic source of real-world examples and genuinely innovative applications that go way beyond just basic caching and offline pages. People get really creative with these things.
I bet. What kind of stuff did they mention?
Well, one user described how they built an offline fallback HTML page. Pretty standard so far. But this page would also periodically check in the background, using the service worker, if internet connectivity had been restored.
Oh, checking by itself.
Yeah, and if it detected the internet was back online, it would automatically reload the full web page without the user having to do anything. Pretty seamless recovery.
That is clever. Much better than just sitting there on an offline page.
Definitely. Another one highlighted was the popular library MSW, which stands for Mock Service Worker.
Oh yeah, MSW. I've heard developers rave about that for testing.
Exactly. It very cleverly uses service workers to intercept network requests during development and testing and provide mock responses right from the browser.
So you can build your front end against an API that doesn't even exist yet, or test edge cases without hitting a real server.
Precisely. And the beauty is, because it uses service workers to intercept at the network level, you don't need to change any of your application's fetching code. It just works transparently. Really smart use case.
That is brilliant.
Yeah.
What other interesting applications did the Reddit community come up with?
Let's see. Several users mentioned using service workers to catch and batch multiple similar backend requests that might happen really quickly, like tracking events or analytics pings.
Patching them up.
Yeah, instead of sending 10 tiny requests, the service worker could collect them for a second or two and then send them as a single, more efficient request to the server, reducing network noise and potentially server load.
Interesting optimization.
There was also an idea for implementing more sophisticated and controlled prefetching of links.
Prefetching. Like loading pages before the user clicks.
Kind of. Instead of just relying on basic browser hints like link rel prefetch, a service worker could more intelligently decide which links or resources to prefetch based on actual user behavior patterns on the site, or maybe viewport visibility or other custom logic. More control.
Predictive loading. Powered by the service worker. Cool.
Yeah. And of course, the ability to provide truly advanced push notification support was mentioned a lot. The fact that notifications can be received and processed by the service worker even when the user doesn't have the website open in any tab, that's a huge benefit compared to older web
It
technologies.
really brings web apps closer to the native app capabilities there.
Absolutely. One particularly intriguing idea, though maybe more for demos or niche use cases, was running a simple HTTP server entirely within a service worker.
Wait, a server inside the browser? How?
Well, the service worker intercepts fetch requests, right? So it could theoretically construct and return responses dynamically, perhaps rendering templates or serving generated content, effectively acting like a mini server just for that client. Useful for client-side rendering demos or specific offline scenarios.
Wow. Okay, mind blown slightly.
Uh-huh, yeah, it's pushing the boundaries. And finally, a really practical one. Caching form submissions locally when a user is offline.
Oh, that's a classic problem. You fill out a form, hit submit, and connection lost.
Right. So the service worker could intercept that failed submission, store the form data locally, maybe in IndexedDB, and then automatically retry submitting it in the background once the network connection is back. Huge improvement for user experience, especially on flaky connections.
That alone seems worth implementing service workers for certain apps.
Totally. Oh, and one more thing mentioned was the library Party Town.
Party Town.
Yeah, it's a library designed to improve website performance by offloading heavy third-party scripts like analytics or ad scripts so they run in a web worker instead of the main thread.
Right, gets them off the main thread.
But PartyTown actually utilizes service workers as part of its architecture to manage communication and proxy requests between those web workers and the main thread. So service workers enabling other performance optimizations.
It really showcases how versatile service workers are, doesn't it?
Mm.
Extending far beyond just making websites work offline. Now, the web.dev article on worker communication patterns suggests that the main part of the website, the page the user sees, and the service worker aren't just isolated entities. They can actually, like, talk to each other.
That's absolutely crucial, yeah. For many of these advanced features, and just to provide a truly integrated user experience, effective communication between your web page, running in the main browser window, and your service worker running in that background thread is essential. They can't operate in total isolation for complex tasks.
So how do they talk? What are the patterns?
The article outlines several common and useful communication patterns. One is called imperative caching.
Imperative caching.
This is where your web page explicitly tells the service worker, hey, go cache these specific resources right now.
Like the page knows something the service worker doesn't.
Exactly. Maybe the user just navigated to a certain section, and the page logic knows they're likely to need related images or data soon. So it sends a message to the service worker to proactively fetch and cache them. It's useful for pre-fetching based on application logic.
Okay. Page tells worker to cache stuff. What else?
Another pattern is broadcast updates. This goes the other way. The service worker can inform all the controlled web pages about important events.
Worker talks back to the page's work.
Right. For example, maybe the service worker just finished downloading and activating a new version of the website in the background. It could send a message to all open tabs saying, hey, a new version is ready, reload to get it.
Ah, like those update available prompts you sometimes see.
Exactly like that. Or
Yeah.
maybe it received some updated data via a push message and wants to let the open pages know so they can refresh their content.
Okay, imperative caching, broadcast updates, any others?
And then there's general two-way communication. This is for more complex interactions where the web page might delegate a task to the service worker.
Offload something heavy.
Maybe, yeah, like processing some data or managing a complex background sync operation. The page sends a message to the worker to start the task. The worker can then send messages back to the page periodically to update it on the progress or send the final result when it's done.
Like a progress bar driven by the service worker.
Could be, yeah. These communication patterns allow for much more sophisticated interactions and create a smoother, more responsive, and integrated user experience overall. They're not just separate silos.
Makes sense. They need to coordinate. Finally, the Study Tonight tutorial on writing a first service worker seems like a great way to take all this knowledge and actually put it into practice. Like, where do you even start?
It provides a really clear and straightforward sort of step-by-step guide for anyone looking to create their very first basic service worker. It demystifies the process.
What's the first step?
The initial step is registering the service worker. This happens in your main JavaScript code, the code that runs on your web page. You use the line navigator.serviceworker.register, sw.jss.
Okay, navigator.serviceworker.register. And SWJS is just the name and location of your service worker file.
Exactly. Assuming your service worker file is named stw.js and you've placed it in your website's root directory, which gives it the broadest possible scope by default.
Right, scope again. And the tutorial mentions best practices for registering.
Yes, it emphasizes, first, always check if the browser even supports service workers before trying to register one. You do that with a simple if, service worker now.
Good practice avoids errors in older browsers.
Definitely. And second, it reinforces that recommendation we heard earlier. Register the worker inside the window.load event listener.
Right, wait for the page to finish loading first.
Yep, window.add event listener, register here. This ensures the service worker registration doesn't potentially block or slow down the initial rendering of your page content.
Okay, check for support, register on load. Then what goes in the SWJS file?
The tutorial then walks you through handling those key lifecycle events inside your sw.js file. It shows how to listen for the install event. The first step in the lifecycle.
Right. Inside the install handler, it demonstrates how to open a new cache using caches.open, cache name, where a cache name is just a string you define, maybe including that version number we talked about.
Caches.open.
And then how to add files to this newly opened cache using cache.add all cache files, where cache files is typically an array of URLs pointing to all the static assets, HTML, CSS, JS, images that you want to cache up front for offline use.
Add all takes an array of URLs. Right. The tutorial also often includes that self.skipWaiting call within the install event handler, at least during development, to bypass the waiting phase and make the new service worker activate immediately. Makes the dev cycle faster.
Skip waiting for faster updates during dev. Makes sense.
Next, it covers the activate event. This is where it shows how to clean up any old, unused caches from previous service worker versions, keeping things tidy. You compare the existing cache names against your current cache name and delete the old ones.
Housekeeping in the activate step.
Exactly. And of course, it explains the crucial fetch event listener. This is the core of the service worker's proxy functionality, where you intercept all outgoing network requests made by your pages.
The fetch handler.
Inside this listener, the typical pattern shown is to use caches.match event.request to check if there's a response already in the cache that matches the current request.
Check the cache first.
If a match is found, a response, you return the cached response using event.respond with response. If no match is found in the cache, you fall back to actually fetching the resource from the network using the standard fetch event.request function, and then you might put the response into the cache before returning it.
Cache first, network fallback. The common pattern.
Exactly. The tutorial usually demonstrates that basic, effective strategy, and it reinforces the recommendation to place your sub.js file in the root directory of your website unless you have a very specific reason to limit its scope just to a subdirectory. Root gives broadest control.
Great. Seems like a solid starting point.
Yeah.
So to sort of wrap up our deep dive today, service workers are these incredibly powerful background scripts. They act as a proxy between your web app and the network.
Right, that proxy role is key.
Enabling a whole host of benefits. We're talking offline functionality, really advanced caching strategies to boost performance, and engaging features like push notifications.
Making web apps feel much more robust and capable.
They have this well-defined lifecycle, install, activate, update, waiting that you need to understand. Debugging requires some specific techniques and tools because of their background nature.
Definitely need those DevTools tricks.
And their versatility is really showcased by all those innovative ways developers are using them, from mocking APIs to batching requests to offline form submissions.
The creativity is pretty amazing.
And the ability for the main web page and the service worker to actually communicate back and forth opens up even more possibilities for creating really rich, interactive, and resilient web experiences.
Precisely. They represent a really significant step forward in the evolution of web applications. They allow websites to become more reliable, significantly faster, and ultimately much more user-friendly. They often bridge that gap in capabilities we used to see between traditional websites and native mobile applications.
It definitely sounds like a technology worth getting to grips with if you're building for the modern web.
Yeah.
So for you, our listener, we highly encourage you to explore the resources we've talked about today, MDN, the tutorials, the articles, and really think about how service workers could be integrated into your own web projects to enhance that user experience.
Absolutely. Dive in and experiment. And maybe on that thought, here's a final question to sort of mull over. As web applications continue their trajectory of increasing sophistication and complexity, really pushing the boundaries of what's possible in the browser, How might service workers evolve in the future? How could they further blur those lines between web and native app functionalities?
Yeah.
Could they take on entirely new roles and capabilities we haven't even imagined yet?
Well,
It's a fascinating area, I think, ripe with potential for future innovation.